Alright, we're going to talk through the most missed problems from Tuesday night's multiple choice set. There are really only two problems that gave people trouble. Number 8 was definitely the toughest one for a lot of people. So this was, if f is a function defined by f of x, what is the x-coordinate of points of inflection for the graph of f? Alright, so if I was betting before starting this one, I would guess that one of these choices has a spot where the second derivative is 0, but does not change sign. And then there's one of these that has the correct inflection points. Inflection points require two features. First, the second derivative equals 0 or is undefined. And then second, the second derivative changes sign at that value. So I'm going to go ahead and find the first derivative and the second derivative. So first derivative is going to be 15x to the fourth minus 20x to the third. And the second derivative is going to be 60x to the third minus 60x squared. Alright, now I want to set the second derivative equal to 0. So 0 equals 60. I'm going to factor a 60x squared out. So I'm left with an x minus a 1. Alright, so we have x equals 0, x equals positive 1. Alright, so when I look at those two possible values, alright, I want to get them on a number line and I want a sign test. So I've got 0 and 1. So if I pick a number out to the left of 0, like negative 5, I've got the first piece here, it's going to be highlighted in blue. Alright, that piece is going to be positive. And then if I take this piece highlighted in yellow, alright, when I'm at like a negative 1, that's going to be negative. So if positive times a negative is negative. Alright, so it's concave down through that section. Then I go 0 to 1. So I'm going to pick a 0.5. 0.5 we get positive and negative again. So that's another negative. So 0 is out because there's no sign change. So now I look at the transition at 1. So if I pick a number past 1, like 5 million, alright, 60x squared is going to be positive, x minus 1 is going to be positive, so this piece is positive. Alright, so we do have the sign change occur at 1. So the correct answer is C, which is 1. Alright, and probably the most commonly incorrectly chosen answer would be D. Alright, I hope that was helpful. Again, always remember, check for sign changes. Sign changes are absolutely necessary to have an inflection point. If you don't have a sign change in the second derivative, the graph did not change its inflection. Alright, jump into number 10. Number 10 says, let f be a function with the derivative defined by f prime of x equals sine x cubed on the interval from negative 1.8 to 1.8, how many points of inflection does the graph of f have on this interval? Alright, so first thing, inflection points happen when the second derivative equals 0 or is undefined. Alright, so I've got the first derivative there, and I'm going to go to my second derivative. So my second derivative, alright, I've got f double prime of x equals, we would have derivative of sine, which is cosine, of x cubed times the derivative of x cubed, which is 3x squared. Alright, so when I look at this, I want to find out when this hits 0 and then in turn changes sign. It did tell me this was calculator okay, so I'm going to lean on the calculator here. Let me get that open. I'm going to move it off to the side just a little bit so we can see everything we're doing there. Alright, so I'm going to go to y equals. I'm going to clear out the stuff from earlier today. Alright, jump back up to y1. I've got cosine, quantity x cubed, close that off, times the 3x squared. Alright, and we've got our second derivative. It said on the interval from negative 1.8 to 1.8. So I'm going to go ahead in my window. I'm going to set my x min negative 1.8, my x max 1.8. Alright, I'm curious about when I have a sign change, so I'm going to hone in right on the x-axis and go maybe just like a negative 1 to a 1 for my y min and max. I won't get a complete graph, but I will get the information I need. So if I hit graph here, alright, I've clearly got 1, 2, 3, 4 spots where there is a sign change. Alright, and then one spot that could be no sign change, or it could be 2 additional sign changes. So I'm going to have to take a closer look at 0 just to make sure. All right. So if I zoom in on that, I'm just going to hit zoom. I'm going to choose zoom box, which is number 1. All right. I'm going to scoot to the left a little bit. I'm going to scoot up a little bit, hit enter. Then I'm going to stretch that out so that it's circling in or boxing in the area that we're concerned with. All right, and keep in mind we've already got 4 other places outside of this. All right, so where our count is at 4. All right, now when I go ahead and I hit enter here, it's going to zoom in just on that box. All right, and again, if we zoom in, we're down to the point where we're at the Y value super close there. So if I move over a little bit, as I keep going, notice that the Y value, as I move through the X values, never changes. All right, it stays a slightly positive number. So we're not getting a sign change there. So no sign change of that. So we have 4. All right, so our correct answer would be C. All right, which is 4 inflection points on this graph. All right, so again, we evaluated that graph. We inspected it a little bit closer as we needed to. We could have set this equal to 0 and solved for those values. That would have probably given us a little quicker picture that at 0 from this factor, all right, we're not going to get a sign change. But again, we can definitely lean on the calculator, which is a little bit easier than necessarily solving that trig portion of the equation. All right, I hope that helps. Those are the 2 that had quite a few misses. Other than that, really great job.